Hi everyone. So to start with my talk, I will show you a 1-minute video on turntaking first.
Stand it though?
Oh, it's really quiet.
Okay. All right. Oh, no, not this one. This is the grand finale of this. Yeah, that's the last one. That's what I was wondering. I don't know what they're gonna do next season because they did some stuff this time. Exactly what I was thinking. Oh yeah.
Okay.
Did you understand it though?
Not again. So these interactions, right, happen among different species and in different modalities. The interaction between the chimps are mainly non-vocal. However, a shared structure across these dyadic interaction is turntaking. So turntaking is characterized by this continuous and largely non-simultaneous exchange, right, of alternating short, flexible turns. In fact, in addition to the animals I showed in the video clip, turntaking is found in a wide range of species, insects like crickets, fireflies, dolphins, whales. So some people would say that turntaking is a foundational infrastructure in communication. Within humans, researchers have found that the timing structure of turntaking is very similar. So as you can see here, the peak, so this is turn transition, is centered around 0. So right after one person's turn ends, the second person's turn starts. And there is a minimum, quickly drops here, amount of interruptions or long gaps. And in fact, we are hypersensitive to timing, and even a 500 millisecond interruption or gap would influence our impression of the conversation. And this tendency of minimum overlaps, minimum gap is found across industrialized and indigenous cultures. The average gap between turn across culture, the mean varies, but the average is around 250 milliseconds, which seems to be a pretty short amount of time to understand the other speaker and also organize your own turn, jump in at the right time. Right, seems like a highly coordinated interaction. Interestingly, turntaking is found in infants as young as 5 months across cultures. And here's a graph from Hilbrink paper longitudinally, right? So since 3 months, infants seem to show this temporal pattern of turntaking. And these early pre-linguistic turn-taking experience is crucial for the development of social-emotional competencies, language development, and even it shapes neural activation longitudinally. However, most studies on turn-taking, including my own previous work, focus on monolingual, typically developing children. And we know that some atypically developing groups, for example, autism spectrum disorder, individuals with ASD struggle with communication, reciprocal socialization, right? So they, in a cooperative task, they seem to be less entrained on the motor, conversational, and even neural levels. In addition, individuals with Down syndrome also experience language delay and behavioral dysregulation. So in this study, we want to investigate the temporal structure of turn-taking in children with ASD and DS. And Professor Venuti kindly shared her data set with us. So in this data set, the subjects are linguistically matched with MLU. My RAs and I annotate the onset and offset of mother-child utterances, and turn translation latency is measured by the onset of the one turn minus the offset of the previous turn. So how does turn-taking look like for children with ASD and DS? Here is what we found. It seems like there is a shared temporal structure among the three different groups. There is variation in mean. I was a little surprised to find that children with typically developing children have a slightly longer turn translation, but that can be explained by the higher ratio of proportion of interruptions in ASD dyads, which is a future direction that I want to look into. So it looks like largely the three groups share a similar temporal pattern of turn-taking. However, this is group level distribution, and it may not capture the individual variability. So compare turn timing on the individual level. We measured the pairwise differences between individual latency distribution with Earth mover distance. So this distance essentially is the work that's needed to change one distribution to another, right? So it cannot be negative, and 0 means that it needs no work. So now we have this matrix, 94 by 94 matrix. Each entry is a pairwise dissimilarity, and diagonal is 0. And we applied hierarchical clustering to this matrix. So the idea is that if distinguishable clusters emerge in this bottom-up way from these pairwise comparison, it would suggest there is systematic group-level differences exist in the temporal pattern of turn-taking. And here is the clustering that we got. And just by visual inspection, it doesn't seem like there are good clusters. We did try to evaluate it with a few coefficients, and these coefficients are close to 0, which suggests that there is little agreement with the true group label. So I think we can say that we did not find systematic group-level differences in the temporal pattern of turn-taking. How about the relationship between the mother and child turn timing, how they relate to each other, right? So for example, here would be a mother-child turn translation. Now it's mother following child. So we did a correlation between the average child-mother and mother-child turn translation for each dyad. And here is what we found. So each dot here is a dyad, right? And you can see the statistics here. Only in typically developing dyads, we found a significantly positive correlation between the mother's turn translation and the child's turn translation. That means that if the mother tends to take quick turns, the child also, on average, take quick, faster turns. So how do the typically developing dyads achieve this correlation? We looked at the sequential level, look at each turn translation timing with lag K autocorrelation, right? So that's just the correlation of this turn translation timing with the how many before. So we especially look at the lag 1 turn translation. So if there is a significant correlation between in a lag K, autocorrelation, it means that the turn timing is adjusted on a sequential turn-by-turn level, like a online adjustment. So here's what we found. We found that only in typically developing children, there is a significant and positive lag 1 autocorrelation. So that means that if if the child takes a faster turn, the next immediate adjacent mother's turn will also be faster. But we did not see that correlation in the other two groups. And we try to find the directionality, right? Who is adjusting to whom? Who is modulating that by looking at the specific mother-child mother, and child, like these turn transition. But we did not find any, explicit, like a clue to who is adjusting to whom. It seems like the effect only came out when we aggregate all the turns together. Okay, so in conclusion, I showed you that beyond the typically developing populations, there is a shared temporal pattern of minimum gaps, minimum overlaps in conversation in children with ASD and DS, so which speaks to this reportedly universal temporal structure of turn-taking. And I also showed you results beyond the central tendency measures, right? So not just looking at the temporal distribution on the individual, dyadic, and sequential level, we found that only TD dyads exhibited temporal entrainment. And this highlights the necessity to examine turn-taking timing in the context of a sequence and in relationship to each other. I would note a few limitations. I think the number one is that our world is multimodal, right? Interaction happens in a multimodal way, and we only looked at vocal turn-taking, and there can be many other things happening at the same time. I also only focused on the temporal, the timing of turn-taking, and did not look at the structural, say, repetition, right, functional words in question contents of the turns. In terms of on the sequential level analysis, there is a mix of alternating and consecutive turns, which may make the lag one autocorrelation a little messy, right? So sometimes they follow their own turn. And I think this work probably is also still within the ableism framework. What does atypically children, what they do not do compared to the typically developing group? Okay, so with that, I would like to thank my co-authors and especially my Italian collaborators for sharing their data. Yeah, thank you.
I already see a question too, so yeah.
Thank you. Yeah, really interesting work. Thank you for sharing that. It's really interesting that you don't find these stronger correlations, and I wonder, going back to your point about the content and thinking about Jack Terwilliger's poster from yesterday, the sort of the nature of turn-taking interactions, whether there would be some kind of functional taxonomy where you could characterize turns, right? That would kind of bring out some more regularities in the timing.
Yes, definitely. I think so. Previous work showed, right? Yes, no questions get faster turns. If it's a back channel word like yeah, that's faster. So I think separating those will probably clean up the results a lot. Yeah, and that's the next step. Looking at the contents of the turns.
Thank you.
Thank you. Sorry. So. If I'm not mistaken, the average age of the ASD and DS groups was about twice as big as the kind of normalized group. Is that correct?
The average age?
Age, yeah. I think it was about 40 to 48 months as opposed to 20 or so months. So I'm wondering if you think that had any impact on the data and the results, or was it intentional that there was that difference there?
Right. I'm trying to find. Yeah. So. I think this is always kind of like a discussion in this literature, and I think a lot of previous studies use linguistic matching to if you were study language, but I think that's certainly possible, and also in relation to the multimodal interaction. So being older definitely also changes interaction in many ways. Yeah, so this is also something that I think about. However, on the other hand, if their chronological age is matched, then their language abilities may be very different, and that's...
Right, yeah, that's what I was wondering. It might have been an intentional decision of designing the experiment, yeah.
Yeah.
So let's thank our speaker. So the next speaker is Chunchi, sorry. And the work is Exploring Tactile Perception for Object Localization in Granular Media, a Human and Robotic Study. So let's welcome